Imagine standing at the edge of the coldest place on Earth. In every direction stretches a vast white desert, an endless expanse of ice and wind where the horizon seems to dissolve into the sky itself. The air is so cold that even breathing feels sharp. Temperatures plunge below -60 degrees Celsius. Storms can appear suddenly, turning the landscape into a blinding white void. It is a place that seems frozen not only in space, but in time. For millions of years, Antarctica has existed as one of the most isolated and hostile environments on our planet. A continent larger than Europe, almost entirely buried beneath an immense blanket of ice. From space, the continent looks deceptively simple. A smooth, white mass sitting at the bottom of the world. But appearances can be deceiving. Because beneath this frozen surface lies something far stranger than scientists ever imagined. For decades, Antarctica was believed to be geologically quiet. A frozen continent resting on ancient rock, unchanged for millions of years. But something about Antarctica has always been mysterious. The deeper researchers looked, the more they realized that this silent landscape was hiding secrets far beneath the ice. Secrets that could reshape how we understand Earth's history, and perhaps even its future. To understand why this discovery shocked geologists, we first need to understand what Antarctica really is. Most people imagine Antarctica as simply a massive block of ice. A frozen wasteland where snow and glaciers have dominated the land forever. But Antarctica is not just ice. Beneath that frozen shell lies a complete continent, a vast landmass roughly the size of the United States and Mexico combined. This continent is buried beneath the largest ice sheet on Earth. On average, the Antarctic ice sheet is about 2 kilometers thick. But in some places, it plunges much deeper, more than 4 kilometers of solid ice pressing down on the land below. The weight of this ice is enormous. Scientists estimate that Antarctica contains around 70% of the planet's freshwater. If the entire ice sheet were to melt, global sea levels would rise by nearly 60 meters. Entire coastal cities around the world would disappear beneath the ocean. But the ice does something else as well. It hides the continent itself. For most of human history, scientists had almost no idea what Antarctica actually looked like beneath the ice. Imagine trying to map an entire continent while it is buried beneath miles of frozen water. Mountains, valleys, rivers, lakes, all of it hidden from view. For decades, Antarctica remained one of Earth's greatest geological mysteries. But during the mid-20th century, scientists developed a new technology that would finally allow them to see beneath the ice. Radar. Aircraft began flying across Antarctica carrying powerful radar instruments capable of penetrating thick layers of ice. These instruments sent radio waves downward through the ice sheet and measured how the signals bounced back. Slowly, a hidden map began to appear. And what scientists discovered was astonishing. Because beneath the ice, Antarctica is anything but flat. Instead, the continent is filled with enormous mountain ranges, deep valleys, and vast basins carved into the ancient crust of the Earth. Some of these hidden landscapes are truly enormous. One of the most remarkable discoveries was a mountain range buried deep beneath the ice of East Antarctica. The Gamburtsev Mountains. These mountains stretch for more than 1,200 kilometers across the continent. Their peaks rise thousands of meters above the surrounding terrain, comparable in size to the European Alps. Yet unlike the Alps, no human eye has ever seen them. They remain completely hidden beneath more than 3 kilometers of solid ice. Scientists often describe the Gamburtsev Mountains as a ghost mountain range, a massive geological structure that exists entirely out of sight. But the mysteries beneath Antarctica did not stop there. Because radar surveys revealed something even more surprising. Deep beneath the ice, scientists began detecting strange reflective surfaces, smooth, flat regions that did not look like rock or mountain terrain. At first, researchers struggled to explain what they were seeing. But eventually, the answer became clear. Water. Liquid water. The idea seemed almost impossible. Antarctica is the coldest place on Earth. Surface temperatures can drop lower than -80 degrees Celsius. So how could liquid water exist beneath kilometers of frozen ice? But the radar signals were unmistakable. Large bodies of liquid water were hidden beneath the ice sheet. Subglacial lakes. Over time, scientists began discovering more and more of them. Today, researchers have identified more than 400 lakes trapped beneath Antarctica's ice. Some are small. Others are enormous. One of the most famous is Lake Vostok. Buried nearly 4 kilometers beneath the ice, Lake Vostok is one of the largest lakes on Earth, roughly the size of Lake Ontario. What makes this lake extraordinary is its isolation. For millions of years, it has remained sealed beneath the ice, completely cut off from the outside world. No sunlight, no wind, no connection to the surface environment. Scientists began to wonder if such a place might contain life forms unlike anything else on Earth. Life that evolved in total darkness. Life that survived using energy from the Earth itself rather than sunlight. The possibility was astonishing. Because if life could exist in such an extreme environment beneath Antarctica, it might also exist in similar environments elsewhere in the universe. For example, beneath the icy crusts of moons like Europa or Enceladus. But the lakes themselves were only the beginning of the mystery. Because when scientists began observing the ice sheet above these lakes, they noticed something unusual. The ice was moving, not just flowing slowly toward the ocean, as glaciers normally do, but rising and falling, almost as if something beneath the ice was shifting. Satellite data confirmed what researchers suspected. The lakes beneath Antarctica were not isolated pools. They were connected. Hidden beneath the continent was an enormous network of subglacial rivers, channels where water flows silently beneath kilometers of ice. These underground rivers can carry water hundreds of kilometers across the continent, sometimes draining entire lakes and refilling others. This hidden water system plays a critical role in how Antarctica's ice sheet moves and behaves. In some places, water acts like a lubricant, allowing massive glaciers to slide more easily across the bedrock below. In other regions, the water becomes trapped, building pressure beneath the ice. It is a hidden hydraulic system that scientists are still trying to fully understand. But as researchers continued studying Antarctica, they discovered something even more unexpected. Something that should not exist beneath a continent buried under ice. Heat. Not just the faint warmth of geothermal energy rising from deep within the Earth, but concentrated regions where the ice appeared to be melting from below. At first, scientists assumed this heat might simply be a natural feature of the Earth's crust. But as the data accumulated, a surprising pattern began to emerge. Because beneath parts of West Antarctica, geophysical surveys began detecting something extraordinary. A chain of volcanic structures buried beneath the ice sheet. Volcanoes. Not ancient volcanoes that erupted millions of years ago and then went silent, but potentially active volcanoes hidden beneath kilometers of ice. In fact, some studies now suggest that Antarctica may contain one of the largest volcanic regions on Earth. Dozens, perhaps even hundreds of volcanoes concealed beneath the frozen continent. And if these volcanoes are still active, they could be quietly reshaping Antarctica from below. Melting ice, altering glaciers, and influencing how the entire Antarctic ice sheet behaves. But what scientists discovered next beneath the Antarctic ice would shock geologists even more. Because as radar surveys, satellite measurements, and seismic imaging improved, researchers began to realize that Antarctica was not just hiding isolated geological features. It was hiding an entire dynamic system. For decades, scientists believed Antarctica was largely stable, a frozen continent resting quietly atop ancient rock. But the deeper researchers looked, the more they realized that beneath the ice, Antarctica was anything but still. In fact, it was moving, slowly, invisibly, and in ways that were reshaping the continent from below. One of the most important clues came from a technique known as seismic imaging. Much like doctors use ultrasound to see inside the human body, geologists use seismic waves to look deep within the Earth. By studying how vibrations travel through rock, scientists can build detailed pictures of structures hidden far beneath the surface. When these seismic surveys were carried out across parts of Antarctica, the results were startling. Instead of a single solid block of crust, the continent revealed a far more complicated structure. In West Antarctica especially, the crust appeared thin, fractured, and stretched apart, almost as if the continent itself had once been pulled in two directions. Scientists began to realize that West Antarctica was sitting on what geologists call a rift system. A rift is a place where the Earth's crust is slowly being pulled apart by forces deep within the planet. Some of the most dramatic landscapes on Earth form along these rifts. The East African Rift, for example, is slowly tearing the African continent apart. Over millions of years, this process may eventually create a new ocean basin. But discovering a rift system beneath Antarctica raised a surprising possibility. It suggested that parts of Antarctica might be geologically active. And that meant the volcanoes hidden beneath the ice might not be ancient relics. They might still be alive. One of the most significant discoveries came in 2017, when researchers analyzing radar and satellite data identified over 90 volcanic structures hidden beneath the West Antarctic ice sheet. Some of these volcanoes rise more than 3,000 meters from the bedrock below, large enough to rival many well-known volcanoes around the world. Most of them are completely buried beneath thick layers of ice, invisible from the surface. But their shapes, revealed through radar mapping, were unmistakable. Conical structures, central vents, layers of volcanic rock. The evidence strongly suggested that Antarctica could contain one of the largest volcanic provinces on Earth. Yet the most surprising part was not just the number of volcanoes. It was their location. Many of these volcanoes sit directly beneath some of the fastest-moving glaciers in Antarctica. Glaciers that are already thinning and retreating. This raised an important question. Could volcanic heat beneath the ice be accelerating the melting of Antarctica's glaciers? Scientists began investigating whether geothermal heat from these volcanic systems might be melting the base of the ice sheet. If so, it could be creating large quantities of subglacial water, water that lubricates glaciers and allows them to slide more quickly toward the ocean. In other words, hidden volcanic activity might be influencing how Antarctica's ice sheet behaves. But confirming this idea proved extremely difficult. After all, drilling through several kilometers of ice to reach these volcanic regions is an enormous challenge. Instead, researchers turned to indirect evidence. Satellite data revealed areas where the base of the ice sheet appeared unusually warm. In some places, the ice above these regions was melting far faster than expected. These hotspots suggested that geothermal heat was indeed rising from the bedrock below. But volcanoes were only part of the story. Because as scientists continued mapping the hidden landscape beneath Antarctica, they discovered something else that no one had expected. Entire valleys carved into the bedrock. Ancient river systems frozen in time. These landscapes revealed a remarkable truth about Antarctica's past. Millions of years ago, Antarctica was not covered in ice. Instead, it was a much warmer continent, one filled with rivers, forests, and even dinosaurs. During the time of the supercontinent Gondwana, Antarctica was connected to Africa, South America, Australia, and India. The climate was far milder. Fossil evidence shows that lush vegetation once covered large parts of the continent. Trees grew along riverbanks. Forests stretched across the land. And ancient reptiles roamed the landscape. But something changed. Around 34 million years ago, Earth's climate began to cool dramatically. As Antarctica drifted toward the South Pole and ocean currents shifted around the continent, temperatures dropped. Snow began to accumulate. Glaciers slowly formed. Over millions of years, those glaciers grew larger and thicker. Eventually, they merged together into the massive ice sheet we see today. As the ice expanded, it buried the entire continent beneath kilometers of frozen water. The rivers froze. The valleys disappeared. And Antarctica became the icy wilderness we know today. But those ancient landscapes never vanished. They simply became hidden beneath the ice. Today, radar mapping has revealed enormous subglacial valleys that once carried rivers across the continent. Some of these valleys are hundreds of kilometers long. One of the largest is known as the Foundation Trough, a massive channel that runs beneath the ice toward the Weddell Sea. These buried landscapes help scientists understand how Antarctica behaved before it froze. But they also reveal something important about the future. Because the shape of the land beneath the ice plays a critical role in how the ice sheet melts. Many parts of West Antarctica sit on bedrock that lies far below sea level. In some areas, the bedrock dips deeper and deeper inland. This creates what scientists call a marine ice sheet instability. If warm ocean water reaches the edges of these glaciers, it can begin melting them from below. As the ice retreats, it exposes deeper basins inland. This allows even more ocean water to flow underneath the ice. The result is a feedback loop that can accelerate ice loss dramatically. Understanding this hidden landscape has become one of the most urgent challenges in modern climate science. Because Antarctica contains enough ice to reshape the world's coastlines. And the forces acting beneath the ice, volcanic heat, subglacial water systems, ancient geological rifts, all play a role in determining how stable the ice sheet really is. But even with decades of research, Antarctica continues to surprise scientists. Because the deeper researchers looked beneath the ice, the clearer it became that Antarctica was hiding something far more complex than anyone had imagined. And what scientists would soon discover about the hidden ecosystems beneath the Antarctic ice would push the boundaries of what we thought life on Earth was capable of. And what scientists would soon discover about the hidden ecosystems beneath the Antarctic ice would push the boundaries of what we thought life on Earth was capable of. For decades, the lakes buried beneath Antarctica remained one of the most mysterious environments on the planet. Sealed beneath kilometers of ice, cut off from sunlight, and isolated from the atmosphere for possibly millions of years, these subglacial lakes represented one of Earth's most extreme habitats. Scientists wondered if anything could truly survive in such conditions. Without sunlight, traditional photosynthesis, the process that fuels most ecosystems on Earth, would be impossible. Temperatures would remain close to freezing. Pressure from the overlying ice would be immense. At first, many researchers assumed these lakes would be sterile. But the deeper scientists investigated, the more that assumption began to change. One of the first major breakthroughs came when researchers successfully drilled through the Antarctic ice sheet to reach one of these hidden lakes. Using extremely sterile techniques to avoid contamination, scientists carefully extracted samples of water and sediment from beneath the ice. What they discovered was astonishing. Microbial life. Tiny microorganisms living in complete darkness beneath kilometers of ice. These microbes were not surviving through sunlight or plant life. Instead, they were relying on chemical energy from the Earth itself, a process known as chemosynthesis. In these ecosystems, microbes extract energy from minerals dissolved in the water, such as iron and sulfur compounds. It is a survival strategy similar to the one used by organisms living around deep-sea hydrothermal vents. For scientists, this discovery carried enormous implications. If life could thrive beneath Antarctica's ice, it meant that ecosystems could exist in places previously considered uninhabitable. And suddenly, Antarctica became more than just a geological mystery. It became a window into the potential for life beyond Earth. Because elsewhere in our solar system, there are worlds that may resemble Antarctica's hidden lakes. One of the most promising examples is Europa, a moon of Jupiter. Beneath Europa's icy crust lies a vast global ocean, possibly containing more water than all of Earth's oceans combined. Like Antarctica's subglacial lakes, this ocean is hidden beneath thick ice and exists in total darkness. Yet if chemical energy sources exist there, perhaps generated by volcanic activity on the ocean floor, life might be able to survive. Another intriguing world is Enceladus, a small moon of Saturn. Spacecraft observations have revealed geysers of water erupting from cracks in Enceladus's icy surface. These plumes contain salts, organic molecules, and evidence of hydrothermal activity deep below the moon's crust. In many ways, Enceladus resembles a planetary version of Antarctica's hidden lakes. Studying Antarctica, therefore, does more than teach us about Earth. It helps scientists prepare for one of the most profound scientific questions humanity has ever asked. Are we alone in the universe? But Antarctica's mysteries are not limited to life. because the continent also holds crucial clues about the future of our planet. Today, Antarctica's ice sheet remains one of the largest and most important regulators of Earth's climate system. The bright white ice reflects sunlight back into space, helping regulate global temperatures. Meanwhile, the immense mass of the ice sheet locks away huge quantities of freshwater that would otherwise raise sea levels around the world. But the stability of this system depends on complex interactions happening beneath the ice. Subglacial rivers transport water across the continent. Hidden volcanoes may generate heat that melts ice from below. Ocean currents interact with the edges of glaciers, sometimes accelerating their retreat. These forces form an intricate network of feedback loops, and understanding them has become one of the most urgent challenges in modern science. Because if large sections of Antarctica's ice sheet were to destabilize, the consequences could reshape coastlines across the entire planet. Cities that have existed for centuries could face rising seas. Entire ecosystems could shift. Global climate patterns could change. This is why Antarctica has become one of the most closely studied regions on Earth. Satellites now monitor the movement of its glaciers with extraordinary precision. Radar instruments continue mapping the hidden landscapes beneath the ice. Autonomous robots explore subglacial lakes and ocean cavities beneath floating ice shelves. With every new mission, scientists uncover new pieces of the puzzle. Yet Antarctica remains, in many ways, one of the least understood places on our planet. Much of the continent's bedrock has never been directly observed. Vast regions of the ice sheet still conceal landscapes that have been hidden for millions of years. Entire ecosystems may still exist beneath the ice, waiting to be discovered. And deep below the frozen surface, geological forces continue shaping the continent in ways we are only beginning to understand. In the end, Antarctica reminds us of something remarkable. Even on our own planet, a world we believe we know well, there are still places that remain almost entirely unexplored. Hidden worlds beneath ice. Ancient landscapes preserved by time. And ecosystems thriving in darkness. What scientists found beneath Antarctica did more than shock geologists. It revealed that one of Earth's most remote continents may also be one of its most important frontiers of discovery. Because sometimes, the greatest mysteries are not found in distant galaxies, but buried deep beneath the ice of our own world.